Alrighty, it looks like it's alive. So, hello and welcome to the .NETOS live webinar. My name is Szymon Kulec and I'm one of .NETOS. .NETOS is basically an initiative, a company that wants and helps to build correct, robust and efficient .NET solutions. Before I introduce our guest, let me try to welcome you in the language that you know beside English. So, hello, I mean, that's English, of course. Cześć. Привет, hola, oi, salut. That's the end of the list. And today we are hosting Marcin Hoppe. I met Marcin a few years back. At the time, I was wearing my engineering hat and I was a bit skeptic in terms of working with the people from the security area. I mean, I was aware of the terms, how encryption works, etc. But actually, Marcin was the person that was able to wear both hats at the same time, an engineering hat and a security hat. So this for me personally, opened a new gate to the land of well understood and well applied security. And here we are today with this live webinar. So during this webinar, Marcin will show us some awesome things related with JWTs and not JWTs. And he will mention things like some basic foundations of JWTs, asynchronous aspects of validating security claims, performance aspects of security, because how could we forget about that during the .NETOS webinar, and a lot more. If you have any questions, please keep them till the end of the session, and we will do our best to address them at the very end of it. And yeah, so we hope that you will enjoy this spicy mixture of performance and security. And without any further delay, please let me introduce and welcome Marcin Hoppe.
Thank you. Thanks for the warm welcome, and thanks for having me. I'm really happy to be here. Let's maybe take a quick look at the agenda today and things we're going to cover. First, I'm going to start with describing a very basic scenario of like API security and how web applications deal with APIs these days. And I'm also using that example, I'm going to introduce JSON Web Tokens or JWTs. Then we're going to see how to use JWTs in ASP.NET Core applications. And this being a .NETOS webinar, we're going to look at the performance. We're going to answer a simple question: is JWT validation a synchronous operation, or is it asynchronous operation, or perhaps both? We're going to try to improve performance. That's what the .NETOS are all about. And we're gonna try to cache some things here and there to try to improve things.
Awesome.
Right. I'm pretty sure most of you are familiar with APIs, most notably like REST APIs, but also things like gRPC, maybe WebSockets, and things like that. And the canonical scenario in things like modern web applications or systems integration is that we have clients that call APIs. Some of the APIs are totally public, and anyone can call them at any time and any number of times. But more often than not, we need to keep the API calls secure. So the API needs to be able to authenticate the client and make sure that whoever is calling the API is a trusted party and that they can access the data they are asking for. Back in the day, a typical solution to this problem was using API keys. So if you wanted to use an API, you went to some sort of developer console, generated an API key, and sent that API key to the API verified it, and either allowed access or not. This solution is very simple, but it has a few management problems. One of them is that the API needs to maintain a database of API keys. It needs to worry about the database storage, things like revoking API keys, expiration, and those sorts of things. So as a solution to that, a common pattern employed is to introduce something called a trusted third party that can allow the client to obtain something, in this case a token, that it can present to the API, and the API can verify that token without maintaining a huge database potentially of tokens. Such a trusted third party is often called authorization server, or an identity provider, or IDP for short. And there are many examples of generic services that can fill this role. One of them is Auth0. Like, full disclosure, this is the company I work for, and this is something we're going to use in the demos, but it's only because this is the IDP I know best. Other popular alternatives in the .NET world are Azure Active Directory, which is an Azure service, and Identity Server, which is an open source alternative that you can either host yourself in the cloud, integrate into your application, or run on premise. And as this sort of pattern was getting popularity, there were two protocols that emerged as sort of leaders in this space and allowed for like standardization, so that different organizations could provide IDPs, different organizations could provide APIs, and different organizations could develop clients. And those protocols are OAuth and OpenID Connect. I'm going to talk about a bit more about the differences between the two in just a little while. So the general flow is that the client sort of obtains a token from the identity provider. This is something we're going to use. Then he takes that token, calls the API with the token, and the API needs to verify that token. And this token verification is going to be the focus for this webinar, and this is something we're gonna look at in more detail. So something that was needed to sort of build not only like a one-off solution, but really like an ecosystem of IDPs and APIs, and allow application builders to build clients, is a token format that's standardized and fairly easy to use. So something that gained a lot of popularity in the last few years and has become like a de facto standard is something called JSON Web Token. And there are a lot of controversies, or there were a lot of controversies about how to pronounce this. So the official RFC actually standardizes the recommended pronunciation, and it's the English word JWT, J-O-T, is how you should refer to it. I think that kind of simplifies a lot of discussions, and like when people say JWT, everybody will know what you mean. So it is a question that's often asked, like, what exactly is a token? In abstract terms, token is a set of claims. So it's a set of statements about who issued the token, who the token was issued for, who the token is about, plus any additional data and metadata that the IDP adds to the token or the client requests. There are three standard claims. The issuer denotes who issued the token, so it identifies the IDP. The audience claim sort of specifies who the token is for. So this is something that identifies the API that the token is to be used with, and the subject. The subject is what the token is, or who the token is about. The token can be issued to an application, and in this case, the subject would identify the application. This is something we're going to see in this webinar, but also tokens can be about humans, about end users of our application. So a subject could be some sort of an identifier of an actual person, a human being. There are also some of the claims are more like metadata, like they denote things like expiration time, when the token was issued, what's the validity period of a token. So tokens can be issued with an expiration time, but also they can be issued only to be used in the future. There are many different combinations of token expiration and validity times that are possible. JWTs were designed to be primarily for the web, so they have to play nice with things like cookies. They can be sent in query string parameters, in HTTP headers. So the format had to be text and not binary, and had to be quite simple. So the general structure of a JWT token is a header followed by a dot, followed by the payload, which is like the information content of the token, followed by a dot and followed by a signature. All of those, each of those components is at the heart of it is a JSON object, but to make it possible to send it in all of those different places, like URLs, cookies, and HTTP headers, those JSON documents are encoded using base64, and to be more specific, with a base64 variant that uses an alphabet that's safe to use with URLs. And the JWT tokens are really very general, so they can serve a number of different purposes. So there is a set of accompanying standards that allow for different types of cryptographic protections to be applied. One of them is JSON Web encryption, and this allows the payload part of the token to be encrypted to ensure what we call confidentiality. And the second standard that is very important, very popular, is JSON Web Signature, and that is meant to ensure that the integrity of the token. And there are two major variants of those signatures. One of them use symmetric cryptography, where both the API and the client need to have a shared key, and it uses a cryptographic mechanism called HMAC to calculate signatures. But if you think about it, this is not much of a progress with regards to the API keys that I discussed in the API security section. So this is not very popular in this particular API security scenario. What's more popular and much more commonly used these days are signatures that rely on public key cryptography, where the party that's signing the token, which is the IDP, or another trusted third party, has the private key, and the party that has to verify the token, which in our case is the API, has the public key, or as we'll see, has to get this public key from somewhere.
Yeah, I wanted to ask about the confidentiality and the encryption part. So that would mean that only the part that is sent the token can actually decrypt it and obtain the payload.
Yes, so it's a prerequisite that both parties, the one that sends the token and one that receives the token, has to have they have to have either shared in some way or exchanged encryption keys.
Okay.
But that would allow us to send information in the token that are secret. Like, for example, if you want to send some sensitive information about the end user, like personally identifiable information or PII, then those are the scenarios where I think token encryption would be appropriate. More often than not, what we're really interested in is preventing that someone like hijacks the token, modifies it, and sends it somewhere else. And this is what we mean when we say integrity, right? So a signature guarantees that the token has not been modified, on the fly.
Perfect.
All right. So this is what I pasted here on the slide is a sample JWT token. You can see the first line is the header. Then we have the dot. Then we have the payload, and then we have another dot, and following that dot, we have the signature. if you're into like maybe cryptography riddles, you can, or other types of encryption, you can, or encodings, you can see that this is base 64, and it has no characters here that would not be playing well with URLs like slashes and so on. What we can do to kind of show you what's inside that token is I can copy it, and I can go to a site that's called jot.io. It's a free jot debugger. What you can do with it is you can paste the token here, and with a little bit of luck, on the right-hand side, you'll see the decoded token. So here in the first box, we have the header. Header contains basically metadata. It contains information about the signature algorithm. It contains the type of the token, which in our case is JWT, and it contains a key identifier to identify which public key was used to sign this token. Further, we can move to the payload. The payload contains, as I said, a bunch of different statements or data fields. We start with the issuer. This is an identification of who issued that token. We can see that this token in particular was issued by my account at .0. The subject is the application that this token was issued to. So that application is someone who's entitled to use that token. And if the API wants to, for example, know if the calling application can access a particular set of data that it asks for, it would typically have to use that field to identify the application based on the token. And the audience claim is an identifier. It's not a real URL, but it's an identifier of who the token is for. In this case, it's our REST API that I will show in just a second in the demo. But right now, it's here is just an identifier, but it's a good way to represent who the token is for. Then we have a couple of different fields like issued at. Those are timestamps and expiration time. We're going to look at that we're going to look at that later on, like where those settings are from. The authorized party is someone who is authorized to use the token. You see, it's roughly the same thing, bearing some minor differences as the subject, and the GTI stands for grant type. It's actually the method that was used to obtain the tokens. In our case, it's the client credentials grant from the OAuth protocol. The last, maybe perhaps the most important bit here is that the signature verified is true. You might have noticed that when I was pasting the token here, this public key here was not pasted, and now we have something that looks like an RSA public key. The JWT debugger was kind of clever enough to take this issuer and figure out where to fetch the public key from, and this is this public key. So it identified that it verified that the signature is correct. If I modify the signature, the verification will fail. So that's a very neat tool if you want to deal more with JWTs. I am pretty sure you'll run into this tool sooner or later.
Yeah, so that goes back to the integrity check, right? Because the
yes,
JWT
exactly.
IO, it was able to first, as you mentioned, obtain the public key and later validated whether or not it was properly signed and not modified or altered.
Yeah, so if I go and try to modify the payload, it automatically says invalid signature, and that way we can identify that the token might have been tampered with, or we have some sort of bug in our application.
Awesome.
And you notice that we started to look at cryptography. So the token was signed. The debugger was able to get the key from some magic location, which we'll learn about later on. But that's the major difference between OAuth and OpenID Connect. OAuth is deals purely with the flow. So it specifies a protocol that allows a client to get a token, to use it with an API, but it says nothing about how the token looks like. It doesn't say anything about cryptography. So OAuth itself is not really helpful to build a fully functional solution, and it specifies nothing about key management whatsoever. OpenID Connect, on the other hand, which kind of builds on top of OAuth, adds those things and a few others, like, for example, the notion of an end user, and it's a much more complete protocol, but it mentions two things that a client needs to get in order to verify a token. One of them is called the discovery document, which provides a set of metadata that are necessary to verify the token. And one of those metadata items is a link to something that's called the JSON Web Key Set, or JWT or JWKS. I don't think the specification for that particular thing specifies the pronunciation, but this is essentially a URL where an application or an API needs to download the key from in order to verify a token.
Okay, so just to be clear, does it mean that we need to get both of them to verify a token?
Yes, pretty much.
Okay, so that sounds as a potential cost for actually the whole validation process.
Yes, absolutely, and we're going to see that in a second.
Awesome.
And the URLs for both are based on the issuer claim. So if you get a token and you're wondering, where do I get the public key from now? Look at the issuer, follow the specification, and you'll get that. So now we have seen JWT structure. So JWT validation algorithm requires a couple of different steps. So you remember that there's a header, a dot, and a payload, and a dot, and a signature. So now we need to reverse that process to get the original token. So we need to split the string with using the dot as a separator. Then we have three different parts. We need to base64 decode them. We need to parse the JSON. Then we need to read the header, and we need to read the claims. And we need to read the claims, and based on that, we will be able to fetch the keys. And when we have those keys, we'll be able to verify the signature, and then the final step is to verify the claims.
Okay, so just to let me try to go through this again. So we basically obtain the token, go through the 1, 2, 3, 4. And that's like a straight decoding of the token. Then we need to fetch the keys, and this will be the two requests that you mentioned before. And then we can proceed with the rest.
Yes, that's true. And the bit that's actually important from a business logic perspective is just the last part. So claims verification is where you actually can go and verify if the client is authorized to access the data they're asking for. So you need to perform all of those processing steps before you can actually get the contents of the token to make your business authorization decisions. And when you think about the performance of this, if you're thinking that, okay, we have an asynchronous operation, that's like an outbound HTTP call, and that's the fetch keys, you were right. Rest of those are synchronous CPU-bound operations that need to be performed before we can actually do anything with the token.
Awesome.
And I totally realize that what you have just seen might have seemed complex. And if you were to implement this, from ground up, or you are, then this is a lot of work. There's a lot of RFCs to be read, a lot of corner cases, writing cryptography code. If you're not doing this as a hobby project, but under a deadline, I would definitely not advise doing that. However, ASP.NET Core makes it remarkably easy to work with JWTs, which I'm gonna show you in just a second. So what I have here is I've built a simple API that's literally almost generated from the .NET New Web API template. And what we have here is our startup CS that configures the whole ASP.NET core application. Not a lot of things here, like really stripped down, really bare bones stuff just to get the routing working and the controllers or everything. And I have just a single controller. It's .NET, so it's a spicy controller, and it returns just a string. So we're going to be looking at performance. So I didn't want to do anything with it like a database, not to to make it as simple as possible, so that whenever we're looking at the performance, we're just looking at that job validation bit that we're going to add. In order to, what I can do is I can start the application. I'm going to be modifying it, so I'm going to do .NET Watch. Boom, started. Okay, it's running. So what I also prepared to make testing this API a little bit easier, I prepared a bunch of scripts. Those are shell scripts. They're going to be available on GitHub. And the first script that we're gonna see and that we're gonna use is to just send a request to the API. This script takes one parameter that is our token. If this parameter is not present, this is what the -z in bash does. It checks if the string is empty. It uses the curl command to send a GET request to our spicy controller, and that's about it. We're going to see this in just a second. However, if the parameter is provided, then it's used in it puts the token into an HTTP header, and this is also something we're gonna see. But this just sends one request. It won't tell us much about anything performance related. So I have another script that's remarkably similar. It takes a single optional parameter, and if that parameter is not provided, we're using a performance testing tool or load testing tool called autocannon to hammer our controller. For 60 seconds, this is what the -d switch does, is how long the test should last, and we're using 500 concurrent connections. If the token, however, was provided, we will append it as in the same way as an HTTP header. I also have one more script that we're going to use that's called get token. This is something that will allow us to ping alt0 to get a token, right? This is something that you can get from alt0, and this script takes one parameter, but this time this parameter is mandatory. So it's a client secret, so it's a secret value that a client needs to present to the authorization server or identity provider, in this case alt0, to get a token. And you'll see this in action in just a second. So we have our REST API running, and now we can call the get API script. You can see that it returned HTTP 200, which means OK, and what we got was our hot string.
Okay, now so that's, as you mentioned, that's just a single call to the controller, basically a single get without any token, because we didn't pass any parameter in there.
Exactly. Okay. So if we get back to the script, we took this first if, so there was no authorization header, no token was passed. And now what we can do is we can run the load test. Again, without the token, our API is totally public right now. And we're going to see in 60 seconds, we're going to see what's the performance of this API on my laptop. That's by no means a beefy server, but it's going to be a fairly good baseline for us to see how much JWT processing when added to a web API, how much does it cost in terms of latency and also throughput, right?
Okay, so now we are hammering this poor controller with 500 connections at the same time.
Yes, 500 different clients hammering our API for 60 seconds.
Yeah, okay, okay.
So we're gonna, in just a second, we're gonna see the performance results along with some statistics. We will not go deep. What I would like, maybe Shimon, I can ask you to maybe just remember a few things. Like the latency, you can see here is in the order of like from 30 to 50 milliseconds most of the time. You can see that the max is, oh my God, like over 6 seconds. But I hope that was only some sort of a warm up. The 99th percentile is 56 milliseconds. I don't actually know if it's good or bad for like an API that doesn't really do anything, but it is what it is. Also, the average throughput was 11,000 requests per second. Again, have no idea if this is a good value, but it's certainly a baseline that we can use. Now, the tricky bit is actually getting back to our application and adding some JWT validation. So the first thing we need to do is we need to add middleware that that will actually verify the tokens. We do this by using the user authentication method in the app configuration, and we also need to use another method that's called use authorization, and we need to add it because later on we will decorate the controller action with an authorized attribute, and we need this this piece of middleware to for that. However, that only signals to ASP.NET Core that we're going to be using authentication. We have not told it what kind of authentication we're going to use. There are different types of authentication, like using tokens, cookies, all the different types of things. So we need to tell it, or we need to configure that authentication pipeline. We use this here in services configuration. We're going to use a method that's called add authentication, and first thing we need to do, we need to pass sort of the so-called authentication scheme name. Later on, I will describe what authentication schemes are, but for now, bear with me. And we're going to use a default, which for our authentication scheme that we're going to use is called JWT bearer authentication scheme. This is a constant, so it's something that JWT bearer defaults. And the value here is called bearer. And now we can use an extension method to add bearer, and this actually tells ASP.NET Core that that our authentication mechanism for the APIs are JWTs. And there's one more thing that we need to do is we need to configure it. So we need to tell ASP.NET Core what it should look for inside the token to make sure that it's valid, right? What ASP.NET Core will do for us out of the box is it's going to handle all the key fetching and cryptography, and it's very nice. However, things that are specific to our API that we need to tell it is which token issuer do we trust. And we need to identify the API, so tell it which, like, how to verify that the token is actually for us. Luckily for us, this is something that the Auth0 configuration dashboard makes remarkably easy. So this is the Auth0 configuration dashboard. What I have done here is I have configured the API in the application. So the .NET's API, or maybe I should have called it Spicy API, you can see that this is HTTP. Maybe I should. It's called, the identifier of this API is http.net.org, something that you've seen in the token. And Auth0 is kind enough to be able to tell me exactly in the quick starts panel, what do I tell ASP.NET Core as those configuration values. So if we get back to the ASP.NET Core and we can just paste it, you can see that we're essentially repeating the same information that we have in a token. So authority configures the issuer that we're expecting, and audience identifies the API, and this is us, .NET.org. This is cool. We're almost done. But if you remember our little controller here, it still says nothing about authentication. And if you want to make this call require authentication, we use the authorize attribute. And right now we're really done. Let me get back here. It looks like the application restarted and should be waiting for us. So let's use the get API again without the token. And you see that previously issuing it without the token returned HTTP 200. Now we got HTTP 401 unauthorized. And this is a signal for us that we need to supply something to authenticate, and this something is here returned as this is the name of the authentication scheme that this particular API endpoint needs to use. So this is a signal for the client developer that they need to provide a token here. And now what we need to do is we can use the get token script to get the token. And what it needs is the client secret. Again, this client secret is something that we're going to get from Auth0, but this time not from the APIs panel, but from the applications panel. And we have a client secret here. It's hidden from us. We can show it, but you can see it's just a blob. We can copy it to the clipboard. We get back and we can call the get token script and provide the client secret that we copied as a command line parameter. And what it prints out is our token. You could actually get this token and paste it into jot.io to kind of see what the structure is. But I'll tell you, I'll spoil the secret a little bit, is that it's almost the same as the token you have seen before. So actually, one thing that I'm going to do to make it a little bit easier for me to work with this token later on is to save this token in an environment variable. Boom, let's check if it's okay. It's a token, and now I can use the get API again and pass the token as a parameter. Boom, it works again. We get HTTP 200. We can call it again. It works. We can also run the load test again and pass the token parameter and wait for a minute.
Okay, so basically now we are using the very same autocannon test that spawns 500 connections or clients at the same time. We are hitting the very same endpoint. The difference is that now it's marked with this authorize attribute, and we are going through the JWT verification.
Yes. So with every request, we have middleware for every HTTP request going through ASP.NET Core pipeline, inspecting that request for JWT tokens, right? And if this middleware detects exactly this header of this form, it's looking for authorization header with the bearer scheme, and it will parse. If it notices something like that, it will parse. It will essentially invoke the entire JWT validation algorithm that we had on one of the slides, the 7-step one, on whatever is following the bearer scheme here.
I see.
And now we have our results back. So you can see my memory is not very good, but I think those numbers were much, much lower. If I remember correctly,
I made some notes. So for median or mean, that was before it was around 30 milliseconds. So now it's 491. And 99th percentile was around 56 milliseconds. And now it's over 1 second.
Right. So that's like that's at least an order of magnitude more, isn't it?
That's correct.
Right. And if I'm not mistaken, the throughput also like went down pretty significantly. It was like in the order of 12,000. Yeah, something like this. And now we have just 1,100. So it seems to me it's a pretty decent performance hit, isn't it?
Definitely.
Yeah. Okay. So you've seen that we're back in the slides. The impact is pretty significant. And when we were looking at the algorithm, we kind of alluded at the fact that we need to fetch 2 keys, and those are really 2 outbound HTTP connections. And that seems like a lot. Actually, there is ASP.NET Core allows you to like configure how you fetch those documents. You can configure something that's called the backchannel HTTP request handler. So it's your own class that kind of the jot bearer handler uses this class to fetch those 2 data items. So maybe there's something we could do there with caching to improve the performance. But the good news is that ASP.NET Core already does caching. And this can be quite surprising when you look at the algorithm, but ASP.NET Core is really like batteries included and a production-ready framework, so it does caching for us. And we're going to see that in just a second. The cache can be configured to some extent. So there are 2 parameters. One is called automatic refresh interval, and this is something that allows us to configure expiry. So if we have a key in the cache that's older than this interval, the ASP.NET Core internals will actually go and fetch the key again and cache it again. It is also possible to flush the cache manually, but ASP.NET Core will not allow us to do it too often. So it's also there's an interval to control that. It's called the manual refresh interval. Interestingly enough, ASP.NET Core does not allow those 2 parameters to be like set too low to essentially disable caching. It's not possible to do. So the minimum for automatic refresh interval is actually 5 minutes. And for manual, you can't like flush the cache more often than once a second. The interesting bit, we're actually running this demo on .NET Core 5, Preview 7. And those 2 values are only configurable starting in .NET 5. In .NET 3.1 or .NET Core 3.1, those 2 values were actually hard-coded. And they were hard-coded, like the automatic refresh interval was set to a day. So if you had your application, you actually were forced to have those values cached for the entire day, which might work for you, might not. If we get back to our code for a little, for just a second, let me get back to our configuration. You can see here that we have options. It's called something that's called the backchannel HTTP handler. What I've done before this webinar is I actually implemented such a handler, and it does a very simple thing. It's just this one thing. It wraps the default handler. That's called an HTTP client handler. That's a class that's coming from the .NET framework itself, or .NET Core. It's not me. And the only thing that we're doing is we're logging the request, the URL of the request that's being made, and then we delegate to the base class. So to this guy. So what I can do here is I can actually install it. It was called new tracing HTTP client handler.
I want to make a note or a remark that usually please don't use console write line in your production code for logging. That's just for demo purposes. And as you saw, probably Marcin is using the task eliding. So he returns after console dot write line. So again, we could go into the async await stuff and discuss task eliding. Let's just focus on JWTs and security right now.
Yes, absolutely. Before we run another performance test, I will go back and absolutely throw this one piece out. And we're just going to run it twice so that you see that the caching works. Actually, let's look at our application restarted, which is great. And then let's use get API again with token. We're waiting. It takes a while, but another hit. I ran it the second time and it was much faster, and again and again. And then if we go to application logs, you can see that it fetched just two documents. One of them is the .well-known OpenID configuration. That's actually the metadata document. And the other one is .well-known / JWT JSON. And this is where the key is. And using this back channel allowed us to check that the caching really, really works. So awesome, good news. We have caching, right?
Great. So basically, let me. So the back channel handler is the HTTP handler that is executed whenever the one of these files is needed. One of these resources is needed.
Yes, okay. Exactly. So if you need to do something like non-standard, this would be your place. This would be your extensibility point. So when I first read about this, that seemed really good. We have caching. However, this doesn't change the fact that our performance dropped by an order of magnitude, right? So we had an order of magnitude, a higher response time, and the throughput was also lower. So I thought to myself, okay, that's fine. It's cool that they're doing that, but what can we do to speed up or eliminate the CPU bound operations? So the splitting, the parsing, the decoding, or the cryptography. So when I started to look at that, I figured out that we would have to basically re-implement all the JWT handling inside the .NET framework, and I was pretty sure that Microsoft has a lot of performance experts on staff, cryptography experts on staff. The chance that I could do something better than them, while I would like to think is possible, is probably not. So what I was thinking, instead of speeding those things up, can we really eliminate some of those computations? And it's an interesting idea because if you think about it, when an API gets a token, if it gets the same token twice, the result of the validation will likely, not surely, but very likely, is going to be the same. So two calls with the same token, one after another, will probably give us the same token validation result. So what I thought is that maybe we could try to cache it, just to short circuit the entire processing pipeline and just cache the results. And in order to do that, there are two things, the ASP.NET Core authentication consists of two major building blocks. If you go and try and configure it, it's a little bit confusing. So let me explain that in a second. What you need to configure is something called an authentication scheme. And an authentication scheme is nothing else as an authentication handler. So this is something that takes a look at an HTTP request and tries to authenticate it. It may be based on tokens, it may be based on cookies, it may be based on maybe even things like mutual TLS on a connection. And a scheme is a particular handler plus its configuration. So for example, we could have multiple, our API could be huge, and we could have different schemes using JWT for different parts of the API. It's really powerful. In the recent versions of .NET Core, what you can do is you can even create policies where you have a block of code that looks at the request and decides which authentication handler to use at runtime. It's composable. It's super flexible. It's also gets complicated very, very quickly.
Okay, so just bear with me for a second. So instead of using authorize at the top of a controller, what you can do is you can write a piece of code that will take a look at the request and properly apply the specific handler to it.
No, it's not even that. In your controller, you would still use authorize.
Okay.
But you could say, I want this controller or this action to be authorized according to a particular authentication scheme.
Okay.
And then you would go to your application configuration that we have just seen and configure like whatever Byzantine configuration you have there for your API.
So you can treat it as a cross-cutting concern, right? And
yes, absolutely.
I see.
Right, and then what we can do to implement caching, we can actually create a custom authentication handler that wraps the one that we already have, the JWT validation middleware, and adds caching on top of that. So the basic idea would be to get the token, see if it's in the cache. If it's in the cache, then return the cache validation result. And if it's not in the cache, we would invoke the built-in middleware. And if the verification or JWT validation is successful, we add that to the cache, so that when we see the same token, next time, we will be able to grab a cached version and then like bypass the whole processing. And
so that would be work on the raw payload, or like the raw-ish payload of the token, and then just short circuit it directly to the validation result.
Yes, absolutely. We're going to see this in just a second. But apart from this being just a clever idea, it turns out to be a pretty viable strategy, because a typical client doesn't come to the API with a new token every time. Because that would be like detrimental to the performance of the client itself. So performance-conscious developers of client applications, they like to get a token and use it as long as they can, which means as long as the token doesn't expire. And you can actually set the tokens to be fairly long-lived. The Auth0 default, we can get here, it's in the API, I think. .NETOS API, it has token settings, and the default is, I know the print is small, but it's 86,400 seconds.
So it's 1 day?
Yes, it's exactly. The token is valid for 24 hours, but you can multiply it by 10 and make it valid for 24 days or a year or whatever. It's configurable. So tokens can be really long-lived. So if you can cache a token that's valid for a year, I say that's probably a pretty good savings. And it's worth bearing in mind, wearing my security hat, that it's always a trade-off between convenience and performance and security. So the longer the token lives and the longer we cache it, the longer we're potentially exposed if someone steals that token or does something to make this token invalid. So there's a little caveat there from me that it's good for performance, but less so for security. All right, and let's get back to Visual Studio and let's take a look at how we might add this caching to our JWT validation.
Awesome.
As I promised, I'm going to remove this line because I have done my fair share of performance tests that were actually like blocked by writing to some sort of console or log file. So I don't want to do that again. I say hello to all my friends who worked with me on those tests. We were young. So the first thing that we need to do is we have a JWT bearer handler class that inherits from the JWT bearer handler. So this is the authentication handler that we use, this one. And what we're actually the only thing that we're gonna do is we're gonna override just one method. We're gonna get to that in a second. But at a glance, what we're doing, what we're adding to this class is a is a memory cache. So ASP.NET Core has a concept of a memory cache. It has a very convenient interface called iMemory cache, and we're going to use it to cache our tokens. This constructor here looks like a little bit like an abomination, but it's what it does, it allows the dependency injection mechanism in ASP.NET Core to give us like all the data we need to create the instance of the base class. And the only other thing that we're getting for our own purposes from dependency injection is this memory cache, which we store in a field here. And the only method that we have overridden is handle authenticate async. So this is actually the part where we look at the request, we try to get the whatever it is that we're basing our authentication decision on. Is it a cookie or is it a token or something else? We kind of get it, we parse it, we verify it, and then we return something called authenticate result. That's also something that's built into ASP.NET Core. So what do? We look at request headers, we extract the authorization header, and then we look it up in a cache. If it's in the cache and we get it in the cached auth result, we just return it. That's it. End of processing. No key fetching, no cryptography, all short-circuited. However, if the header with the token is not in the cache, what we're doing is we're calling the base implementation. It's an asynchronous method, so we have to use await. And I'm pretty sure Szymon knows a lot more about this, what happened in this line, than I ever will. And if the authentication result is successful, then we just add it to the cache, like the whole header as the key and the authentication result as the cached value, and then we return the result and we're done. This is our magic trick. We also have an extension method here that does a little bit of magic to register that our custom authentication handler with ASP.NET Core middleware. This is not something you would typically have to do. And if you have, thanks to excellent documentation and ASP.NET Core being open source, you can go and figure out what this does pretty easily. What it means for us in terms of using it, we can go back. We can go back here and we can exchange the change the add jot bearer. This one was called add caching jot bearer, and this is what we're going to do. We're just caching. Just add one word. Brilliant. There's just one last thing that we need to do. Yep, preview 7. Don't use that in production. One last thing that you need to do, you remember that we need this iMemory cache thing injected by ASP.NET dependency injection. To make that possible, we need to add a service, add memory services. Whoa. Add a memory cache. There we go. Boom, restarted. And let's get an API. Let's see if it still works. Boom, it works. So that means we can safely go and run our load test again.
Yeah, so again, we are hammering it with 500 clients at the same time.
Yes, those of you who are really like savvy and have big applications handling a lot of load might notice that this iMemory cache interface is synchronous because this is a local in-process in-memory cache. We used it here in our demo because it's very simple to use. But ASP.NET Core has also a concept of a distributed cache. So this is cache that exists out of process. It can be some Azure service. It can be Redis. It can even be a SQL database. And access to this cache would have to be asynchronous. So instead of this if memory cache try get value thing, we would have to make an asynchronous invocation that under the hood would do some I/O, hopefully to something that's on the same network segment or has very low latency.
Yeah, again, this method is async friendly. I mean, it already returns the task, so you can await as many times as you want to in its body. Beside calling the handle authenticate async, of course, you could call that the I-distributed cache that Marcin mentioned.
Yes, absolutely. Okay, and Shimon, be my memory. How does this compare to the numbers we have previously seen?
Okay. This looks pretty awesome. I mean, mean median in the very first run without authentication, that was 30 milliseconds. Now we can see that it's 40, so it's 1/3 longer. For the previous, it was 400 something. So it looks awesome. For the 99th percentile, without authorization, we had 56 milliseconds, and now it's only 2 times bigger. And in the previous attempt, it was 10 or 20 times bigger. So again, amazing result. And for the throughput, where's the average? Okay, so the very first test was around 11,000 requests per second, and now we can see that we are at average.
It's even better, I think.
I mean, the result is amazing.
10,000. It's almost as good.
Yeah.
So the memory cache here definitely has a cost, and if we had an application that doesn't fit into a single web, because this caching works per web server, right? So if we had, for example, an application that consists of 2 web servers behind a load balancer, each of those processes would have its own cache. So that means like the memory consumption would be twice as big, because every one of those web servers would have to have their own cache. With the distributed cache, like we only cache every token once in some place, like Redis or something else. But then the price we pay for that is obviously one more network connection. So that might or might not be a good trade-off, depending on your scenario.
Yeah, and again, you can easily wrap the I-distributed cache in another layer, so to have some kind of like a bit of local cache and then fall back to Redis. So you can stack it up, and again, as it's async friendly and async aware, you can use it in the method that you mentioned with a single await, and just leave it for the implementation to deal with properly handling of expiration and all that stuff behind it.
Yeah, absolutely. So ASP.NET Core has an in-memory distributed cache. It sounds like a little bit of a misnomer, but it's essentially implementation of that async interface that caches things in memory. So you're right that we could create like a composite implementation that tries to cache things in memory and offloads to Redis. So it could implement things like, I don't know, having some sort of hot path with the most frequently used items, or use another strategy of this kind. Definitely possible. So as usual, there are some caveats. Like this strategy works almost or most of the time. There are a few scenarios, or there's one scenario that it doesn't handle very well, and that is key rotation. So when you have a private key that you use to sign tokens, it can either be it can be rotated for a number of reasons. There are different like compliance requirements that require keys to be rotated every now and then, like in response to some events, such as maybe like a data breach, or even on a schedule, like every 3 months, every year or so. Our solution doesn't really cover for that, and there's absolutely, like, we cache our current code caches tokens forever, right? So if there was a new token issued or a new token signing key issued, but we had cache tokens that were signed with the old key, we would always honor those tokens, even though oftentimes the key rotation is done exactly to invalidate past tokens, right? So this is something that that we would have to implement separately and react to key rotation event and essentially flush the cache. The interesting bit is that ASP.NET Core metadata and key caching has exactly the same problem. And what they do is they just keep it in the cache until it expires. And then if the key was rotated, they just pick it up with the next fetch. So they have to do something similar anyways. And the second bit, it has to do with verification of claims that are based on time, especially the expiration claim, so the EXP. Because as I said, we currently cache tokens forever, and tokens, they can have a long expiration time. They can live for very long, but they will eventually expire. And then we probably need to extend our caching middleware to take that into consideration and verify those time-based claims all the time. Sadly, this is not very trivial because you have to take clock differences, clock skews, and things like that into consideration. So we decided to leave it as an exercise for the reader because it's difficult, error-prone, doesn't improve performance. So we thought it wouldn't be a good addition to the webinar. But it's definitely a good exercise and something that's going to be necessary if you're going to implement this strategy in your own system. Okay, that was a very long ride. Hopefully you had fun, as much fun as I do. So if you are to get something out of this webinar, I'd say 4 things are stand out to me. The JWTs are super well supported in ASP.NET Core. It's really built in, super easy to configure, as you've seen, and it really hides all the complexity. And it's super easy to integrate with existing identity providers. As I said, it works with Auth0, it works with Azure AD, and it works with Identity Server out of the box. And you've seen that JWT is it's neither synchronous nor asynchronous. It's a mix of both, which technically makes it an asynchronous operation, but we've seen that with some clever caching of the asynchronous part, we're left with a pretty significant performance penalty just from the CPU bound operations. And that ASP.NET Core is really smart about caching. So I was really pleased to see that without me doing anything, the caching was there out of the box with pretty reasonable defaults. And if you want to, you can be more aggressive with your caching and cut out all the processing yourself with some minor tweaks. The code you've seen was not terribly complicated, I think, for the performance benefit that we've seen.
Yeah, definitely. Marcin, thank you for this awesome webinar. I hope that you all enjoyed. It was a really interesting success path from starting with the just use the HTTP controller, try out how it works, then observe how caching is applied in the .NET 5 itself for the mentioned metadata that we need to obtain, and then we ended with a really huge performance improvement just by caching. So that was a really interesting ride, actually. Please, if you have any Q&A, sorry, maybe not the answers, but the questions for Marcin, please use the comments section to paste them right now. We have at least one, as far as I can see, so we will start answering them in a few seconds. The last but not least, a short call to action. I would really want to encourage you to share any security-related topics that we could cover during future webinars with Marcin. And there is a survey link provided in the description of this webinar, so you can just follow it. And I don't mean any like the abstract security questions, but we would really rather focus on something that we could help you with in a day-to-day work. So something like Marcin did today with application of caching and improving greatly the performance and the throughput of this HTTP controller secured with this attribute. So please don't hesitate. Just share what you would like to learn using the link that is provided in the description of this webinar. And now let's move to some questions. So I will use this magic trick to pop up the question. Yeah, so the first is about the token expiration. But Marcin, can you say it? Should I read it loud?
Yes, absolutely. I can read the question. So what is the best practice? How long the token should be valid? I know it depends, but I personally think if it lasts a year, that's too long and not secure. So unfortunately, the only answer I have is that it depends. Because like there are tokens that, for example, when stored in a very secure fashion in a backend application that's used just to read not very secret information, then maybe a token that's valid for a year is a good solution. However, there are many situations where you want the token to be very short-lived. Like for example, tokens that are issued to just for a single transaction should probably have expiration time in the order of minutes. And it makes a tremendous difference who you issue the token to. So if you issue the token to a backend application that can store it in a secure location, perhaps even encrypted with, for example, in the cloud and with a service like Azure Key Vault, then you could have that token be like longer lived. But for example, if you have tokens issued to mobile applications or applications running in a browser that are inherently less secure than backend applications, then those tokens should probably be fairly short-lived. But it all depends on your particular application. It depends on your tolerance for risk. And essentially, you would have to, what you would have to answer is the question, okay, so for how long am I able to tolerate that someone has stolen that token and is using it before it expires? To give an example from the media industry, one of the customers that we were working with said like 30 days for a token is okay, because the worst thing that can happen is that they had a system that they were protecting some content and they were selling their customers monthly subscriptions. So they said like, okay, like a token that's valid for a month is fine for us, because the worst thing that can happen is that someone has access to someone else's news articles or sports results for an additional month. And they said like, so what, right? So this was the risk tolerance. And I think those are the kinds of kind of discussion and thinking that has to go into like determining token expiration times, which, by the way, is very valid for how long we should cache the tokens. It's exactly the same type of consideration.
And that would resonate with something that you mentioned about the specifying schemes and handlers. I mean, in this cross-cutting concern, where you can define that this specific area is protected in the specific way. So meaning that you can differentiate or split your application or API endpoint in different areas that are protected differently, maybe?
Yes, absolutely. So getting back to the like the media company, so something I would imagine that the API that kind of serves the content can have one level of sort of security requirements and can be a little bit more relaxed about what kind of tokens, like how long the tokens live. But for example, an API that allows an administrator to manage subscriptions I would imagine that those tokens would be valid for a shorter period, if that makes sense. And you can totally address that with different authentication schemes within ASP.NET Core. So you would have two schemes in this case. Both would use the JWT handler, but they would have different configurations. So they would have different values on this options object that we have seen. And the only thing that you have to do in like the business logic of your application, which is in the controller, you would have to specify, okay, this controller and this action uses this scheme, and that another uses another one. Right, so this is a very convenient way of like separating the business logic from the details of the implementation.
Awesome. We have a question related. Sorry, not that one. About the source code. Could you later on paste the link to the demo? Is it publicly available?
Yes, both the slides and the demo is available on GitHub. We will add the link after the webinar.
Okay, so it will be. Yeah, it will be added either in a comment, or we will just amend the description of this video to include it. There was also the question related where you were showing the caching approach. That was the first part of the question, where do we cache the token, and the second about the cookie. My answer was that I gave. Sorry, I don't want to steal the show, but I gave the answer that and correct me if I'm wrong, the caching is on the API side that wants to validate token that is sent to it. So yes, we don't want to pay the cost of the validation, but we are not the one that store the token somewhere. We just want to validate it and ensure that the validation result is okay, so we can proceed with the API call itself.
Yes, absolutely. And really, like the question about the cookies, it's right now, our example was a backend application calling an API. So in this context, the cookie is just another HTTP header. So it would be exactly the same, right? So on the backend side, the authentication handler that handles cookies works in exactly the same principle. So it's a middleware that's added to the HTTP request pipeline, and the handler has to look at the request. It wouldn't look at the authorization header. It would look at the cookie header and extract the token from there. So it doesn't matter in this scenario. Where it matters is in the browser scenarios where within the browser, cookie is really a protected file, where cookies are protected by the browser. And what happened, like for our scenario, we're on the backend side, as Shimon said. So it wouldn't matter if it's sent in one header or another. From performance perspective, it doesn't matter. It matters from a security perspective, in that if you're storing it in a cookie on the client side in the browser, it would get some level of protection. If you're storing it in some other place, the level of protection might be different.
Okay, yeah, that's something that I didn't take into consideration, that we were basically showing the scenario where a backend application is calling the API endpoint. So therefore, we can use whatever header that we want to. So yes, it could be either the cookie, because that's just a header whenever you send a request, or as we use the token bearer header. Awesome. Another one from Przemysław.
Do you have any knowledge about any other kinds of tokens than the JWT, pros and cons, when to use, etc.? So I'm going to assume that we're going to stay in the sort of OAuth and OpenID Connect world, because there are loads of other types of tokens. For example, we can have instead of JSON, we can have XML files with XML digital signatures. This is kind of the type of token that's used in an older authentication protocol that's called SAML, Security Assertion Markup Language, which is like kind of the same thing, just built on XML and XML digital signatures, but very comparable. But within the OAuth world, there are two major types of tokens. One of them are JWTs, which if you're using OpenID Connect, it's kind of sort of the standard because OpenID Connect kind of mixes two things: API security and authentication. For the authentication part, it really forces you to use JWTs. There's no way to use anything else. For the API security that's taken straight from OAuth, OAuth really doesn't tell anything about the token, like the token format. So a lot of people these days just use JWTs as we have because it's so convenient and it has a number of benefits. But another major type of token is, for example, identity server folks call it a reference token. So it's just a blob. And it's essentially the same mechanism as API keys in that we get a authentication or this identity provider and third party, the trusted third party essentially sends us a blob that we need to send it to the API, but then the API has to have some way of verifying if that blob is correct, and it's usually through a mechanism that's called OAuth introspection. So the trusted third party has a separate endpoint that's not used by the client, is used by the API to send that blob and get not only information about whether this blob represents a valid token, but also it can send back other claims that we've seen, like the issuer, the audience, and the subject. And every now and then, someone comes and proposes a new token format. Like Paceto is one that has recently gained some attention. There's a token format called macaroons that allows for things like delegation of permissions and things like that. But in practical scenarios that I've seen, it's like JWTs are like super popular and very widely adopted. So for reasons that are not exactly technical, they are the dominant standard.
All righty. We have two more, so I think that we can probably try to answer them, and then we'll be wrapping up. So this one is from Grzegorz.
Okay, should we care about key rotation? How to implement periodic key rotation? In general, yes, you probably should. Just for hygiene, if nothing more, because if the system is working, like if you have requirements for key rotation, then you have requirements for key rotation. They may come from compliance, they may come from the security team within your company, whatever they're coming from, their effective life, and you have to do them. From like a risk management perspective, key rotation is useful as an incident response mechanism. So something happened, you maybe know that your assigning key was leaked, or your database with your keys was breached, or you're just suspecting that, you don't quite know. But in order to like remediate the situation before the investigation is over, you need to do key rotation. So usually, yes, key rotation is something you sooner or later would need to think about. The good news is that if you're using a third-party provider, then they should provide it for you. From a protocol and standard perspective, the file we have seen is being fetched, the JWKS, the last word there is for set. So it's not really a single key, it's a set of keys. So you would then have like your new key if you're rotating, and potentially also for some period of time, you would be getting your old key so that you could, for like the transition period, also verify other tokens. If I get to the JWT debugger, in the header, there's also this key ID field over here. That is an identifier that allows you to find the proper key in the key set file if there are more keys. So this is something that allows you to have support for multiple signing keys at the same time, not necessarily all of them actively signing tokens, because that's usually only one is signing tokens, but to verify all tokens for, as I said, some period of time where you don't want to cause like a disruption for your clients or lock them off. You may want to accept the risk of even you rotated the keys, but you will accept all tokens for a few more minutes or something like that. So that is a mechanism that allows you to do that. I hope this answered the question.
Yeah, so basically you can do, I'm not sure if that's the phrase, but you can do these kind of like a soft key rotation where the previous key is still valid, but
but it's only valid for verification. It will not be signing new keys in this transition period.
Okay, interesting. Okay, so the last but not least.
How would you enable trusted subsystem workflows, App API, DAL, database on Azure AD or OAuth 0? I must admit I'm not quite sure what you mean by trusted subsystem workflows. Can you elaborate on that a little bit?
I think that due to lag in the comment section, we might need to wait for a while.
Okay, so I have a hunch about what this question is about. So I'll take a shot if that's the my interpretation of the question is wrong, then I'm easy to find on the internet. So feel free to shoot me an email. Sure. There are API security scenarios vary. So there are things that are have lower security requirements, like for example, getting back to the media example, like the API that serves content that's it's the revenue stream, but nothing happens if just one customer is sort of compromised. But if that same company is running in a totally public cloud infrastructure, and for example, you have your database in as a managed service, for example, on Azure, then an access token for an API for that database has much stricter security requirements, right? And for those cases, it's like the same architecture applies really. Although if you go into Azure, you will see that API keys and things like that are still supported. But in general, JWT is just fine for those scenarios as well. It's more about how does the trusted third party or identity provider, how do they authenticate the client that wants to obtain the token, right? Because if you have a browser application, then you can't really store any sort of secret in a browser application because it can be easily not really decompiled to just go and open a source of a website and you would see it right there, right? So there isn't a variant of OAuth and an OpenID Connect that's for lower security environments like the browser, where you don't really have to present the client secret to get a token. You just present yourself with a client identifier, and it's kind of your decision to accept that risk of issuing a token to a lower security environment. However, in this higher security environments, you would typically require more credentials for the client application to present to the trusted third party to get that token. In our case, we really were not very, very strict in that we only had one, just a client secret. But I can imagine that you could have, for example, to issue a token for a very, very, very restricted resource like a database API or something like that, you could require more credentials. Like, for example, you could verify the client secret. You would require, for example, a client TLS certificate that's issued by a trusted certificate authority and things like that, and maybe even limit, for example, the IP range of where legitimate clients may be coming from, things of that nature. If I understand the problem, the question correctly, of course.
So again, it's a bit like a sliding scale, right? You can just think about more dimensions of like you mentioned, like adding the IP range and TLS client certificate whenever it's needed.
Yes. So I think the best way to think about it is like adding more and more credentials or authentication factors, right? If you have like a banking website, they are required now to add second authentication factor, right? Like no one in the right mind would issue an access token to your bank account to a public web application that just isn't the browser and it's easy to inspect the source code. You actually need to provide user credentials, use your username and password, and then a second factor authentication is triggered.
I see. Awesome. Perfect. Marcin, it's almost 1.5 hours. So again, thank you very much for showing us the path to really fast JWTs and showing all the steps that enabled us to actually reach this beautiful, really fast running controller still that is secured by JWTs. And let me remind you again, if you have any real live work-related scenarios that you would like to be covered in future webinars, just use the survey under the you can find a link in the description of this webinar, and don't hesitate. You can flood us with the questions. We'll just properly filter them out and find out what should we cover next. So thank you very much for being with us, and hopefully see you soon.
Thank you. Thanks for inviting me, and I was really happy to be here. Take care.
Awesome. Take care. Bye-bye.